Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter A of our diesel engines class. This is the chapter A. Today we are going to talk about the crankshaft and the connecting rods. We are going to study the different type of crankshafts, the material of the crankshaft, the dynamic balance of the crankshaft, and we are going to verify the connection in between the connecting rods and the crankshaft. In this next episode, we are going to talk about the bearings, and we are going to talk about the techniques used to verify the clearance, the tolerance in between the bearings and the crankshaft. Okay, we are going to start with the theory related with the crankshaft. What is the function of the crankshaft? The crankshaft is another vital component in a diesel engine. The crankshaft is the element that converts the vertical movement of the piston into the rotational output of the crankshaft. It's the element designed to convert vertical movement of the piston up and down into rotational speed, RPMs, and produce torque. And don't forget the vertical movement of the piston is because the explosion on top, on the head of the piston, because in this pocket all the forces are concentrated in order to transmit the force through the center of the connecting rod. This is one of the functions of this pocket in a diesel piston engine. That pocket is used to concentrate all the forces exactly in the middle of the connecting rod. This is one of the functions of the pocket in the piston of a diesel engine. Okay, we are going to check the components. This is the front of the crankshaft. This is the rear of the crankshaft. The flywheel is located over there, and the harmonic balancer in front. Let me tell to you something. In the installation, the calculation of the crankshaft is very important. The harmonic balancer in front of the crankshaft and the flywheel in the back of the crankshaft. Both elements are bolted with the crankshaft, and they work together all the time with the crankshaft. For that reason, we are going to study later the procedure to do the dynamic balance on the crankshaft. In order to do the dynamic balance, we are going to use the harmonic balancer in front, the flywheel in the back, and the connecting rods and the pistons, all of those elements together with the crankshaft in order to balance the engine properly. And I'm going to explain why it's necessary to do the dynamic balance in a diesel engine. Alright, we have the harmonic balancer in front, and this is the gear of the crankshaft, and in that point is located the seal, the front seal, the seal that is located in the timing cover. In the timing cover, you found that seal. This is exactly the same seal that you have in the back. In the rear, you have another one. You have the rear seal on the crankshaft and the front seal on the crankshaft. Remember, both seals are critical for leaks. 90% of the leaks in an engine, gas or diesel, is through the seals, front seal or back seal. Yeah, those are the seals that commonly are with problems, and the leaks are over there in one of those seals. What is the procedure to remove the front seal? You need to remove the timing cover and replace the seal. What is the procedure to replace the back seal, the rear seal? You need to separate the transmission, and you need to remove the flywheel in order to get access to the seal of the crankshaft, the rear seal. Yes, you need to remove the flywheel because it's behind of the flywheel. Okay, let me continue with the video. Those are the seals, and those are the main journals. And those are the caps. Those caps are bolted on the block. We are going to see later that bit. Those are the main journals in the center, in the axis, in the center of the crankshaft. And on the rod pins, you have the pistons, crank pins or rod pins, rod connections. All right. Those are the pistons. The pistons are connected with the crankshaft by means of the connecting rods. What is the procedure to keep the crankshaft in balance? What is the procedure to keep the crankshaft rotating with the properly balanced in order to avoid vibration? This is because in front of the piston with connecting rod, we have the counterweights. The counterweights, those pieces of metals located in front of the pistons, have the same weight than the piston plus connecting rods. Those elements, they have the same weight than the piston with the connecting rod together, and keep the engine rotating smooth. Like this. This is exactly the situation. Those are the connecting, the counterweights. Those pieces of metal, if you see on those drills, are used when the people balance the crankshaft. They remove material on the counterweights, or they added material. In those drills, those holes that you see on the screen right now, you can introduce set screws in order to add additional material. Or with a drill bit, you can remove material. We are going to check right now in this episode the procedure to do the dynamic balance in a crankshaft, in a typical crankshaft. Yes, the counterweights, the weight of the counterweight should be equal to the weight of the piston plus connecting rod plus rings. The weight of this element should be equal to the weight of the counterweight. Right now we are going to do the procedure to do the dynamic balance, and we are going to check that procedure. Okay? This is exactly the procedure. This is the counterweight over there, and in the opposite side you have the piston with the connecting rod. In order to keep the balance, the weight of the counterweight should be equal to the weight of the piston plus connecting rod. Should be exactly the same. Weight in order to keep the engine on balance. Alright, counterweights and piston with connecting rods. Okay, right now we are going to check quickly the different type of materials used to fabricate the crankshafts. The crankshaft is basically a steel with a low content of carbon. Normally it's in between 0.2 and 0.4% of carbon. It's a low content of carbon. But the majority of the crankshaft, especially the marine crankshaft, they have high content of chromium and molybdenum. Chromium and molybdenum. My friend, I want that you keep in mind the main components on the alloys of each part, because in 2 chapters I am going to explain the analysis of the oil. We are going to talk the sample of oil in a diesel engine, and we are going to send the sample of the oil to the laboratory, and when we receive the report from the laboratory, we are going to analyze what elements are with higher level than the normal, and we are going to analyze element by element, and only with the sample, only with the result of the laboratory, we can do the diagnosis in any type of engines. And we can say the engine have low compression, the engine have problem in the heat exchanger, the engine have problem on the crankshaft, the engine have the piston rings broken. You can give exactly the analysis only checking the oil sample report. Exactly the same like when you visit the doctor. When you visit the doctor, the first step is take a sample of blood. And the next day, when you visit the office of the doctor have the report, and the doctor said, oh yeah, you have high level of iron, low level of zinc, and according with this, your problem is this or this or this or this. It's exactly the same. We are going to do exactly the same with the sample of oil. We are going to send to the laboratory in a plastic container, like the container that you have on the screen right now, the sample of the oil, and we are going to send another sample, the sample of coolant. And with both samples, we know exactly what happened internally in the engine. For example, if we found it in the report of that sample, high content of chromium or over the limit, or high content of molybdenum, you have deterioration of the crankshaft. What is the meaning of that? You have problems on the crankshaft? Probably you have problems on the bearings. If I have problem on the bearings, probably I have high level of lead and high level of zinc. Let me check the content of zinc and lead. Yes, they are high and high. I have problem with the bearings. If I have problem with the bearings, probably I have one code on the computer. What happens when the bearings have too much wear, too much play in between the crankshaft and the caps of the main journals or the caps of the rods? If you have too much play, you have a knock sensor. You have the code of knock sensor. This is an indication that you have too much play on the bearings. And you have additionally other problem in the engine. When you check the oil pressure gauge, the pressure is below 40 psi. This is an indication that you have too much play on the bearings, low oil pressure, and you have a knock code activated. Alright, but we are going to study later in the chapter dedicated to the codes that situation. Alright, it's important that you remember, that you memorize the main components on the alloy of each element. And we are going to start right now with this one in particular, the crankshaft, high level of chromium and molybdenum. Okay, for that reason we are going to memorize those elements in the future when we analyze the oil sample, check the chromium, the molybdenum, and we are going to identify if we have problems on the crankshaft. Alright, other important thing is about the forces. Remember, all the forces are produced on the head of the piston and are concentrated in this small pocket. Yes, this is important in diesel engines in order to improve the performance of the engine when they concentrate the force in the center of the connecting rod. Yeah, they are the majority of the forces are concentrated here in the center, because all the piston, they have the pocket, and all the forces are concentrated here and here. Right? This is a good design, specific in diesel engines. My friends, don't forget that the diesel engines produce higher torques in comparison with any other type of internal combustion engines. You remember how much is the average of a pressure produced in the combustion chamber? Look, it's around 3000 psi or higher. 3000 psi is a lot. 3000 psi is the average of pressure in the combustion chamber. With that pressure, you can produce a high torque. You remember the formula for torque? Torque is equal the force times the radius. Is equal to the force, this force times the radius. The radius is the distance in between the center of the crankshaft with the center of the crank pin or rod pin. Okay, this is the radius. If you know the vertical force, no, I don't have the vertical force. Yeah, you have the vertical force because you have the pressure. And pressure is equal the force divided by the area. Pressure is equal to the force divided by the area. You know the area. This is the area of the head of the piston. This is the area of the head of the piston. And you know the pressure, 3000 psi. With that one you can calculate the force. Simple. And you know the radius because you have the crankshaft, the dimension of the crankshaft. You can calculate the torque produced for the engine. This is simple. We are going to do that calculation later. But this is basically an introduction for that information. Okay, my friends, don't forget the diesel engines produce higher torques. Because the diesel engines produce huge torques, the diesel engines produce huge momentum. What is the momentum? What is the meaning of momentum? The momentum is the inertia produced when an object is in movement. This is the momentum. Yeah, of course, when a diesel engine is running with 6, 8, 10, 12, 16 pistons spinning at the same time, is easy to stop a diesel engine? No, it's not easy to stop a diesel engine. For that reason, you hear that when you turn off a diesel engine, the diesel engine try to stop, but it's not immediately like in gasoline engines, because the momentum of the pistons in constant movement on the crankshaft create an equation that is difficult to stabilize in the other side of the equation. In our course of hydraulics, I am going to explain that phenomenon. Other forces that affect the performance of a diesel engines are the axial force on the crankshaft. Those axial forces are produced on the transmissions, and specific in marine applications are produced on the propeller with excessive pitch produce too much axial force and affect the performance of the diesel engines. For that reason, the life of the engine is reduced when the boat works with high pitch all the time. Yeah, the selection of the pitch is according with it. You remember, with the length of the boat, the type of hull, the horsepower of the engine. There are a lot of considerations in order to protect the engine, and one of the considerations is don't use excessive pitch on the propeller. But we are going to talk later about that situation. Okay, other important consideration in the life of the crankshaft is the lubrication. Today we are going to talk a little about the cavities used to pass the oil and keep the crankshaft properly lubricated. All the problems in an engine start with a lack of lubrication. Lack of lubrication is the beginning of all the problems. If you have high temperature in your engine, it's because you have a lack of lubrication in any part internally. If you have lack of lubrication in some bearings on the crankshaft, in a couple of minutes, the soft metal, the white metal, the babbitt on the bearings is destroyed, the temperature increase, and in a couple of seconds the metal is fractured. Yeah, the metals internally in any type of engines are fractured because excessive torque, excessive load is produced, and because the lubrication is not appropriate. Is possible fracture the crankshaft? Yeah, it's very possible, especially in marine application is possible. Suppose we are going to continue with the momentum. Suppose that the engine, the diesel engine, is running, and suddenly salt water enter in one cylinder. What happened immediately? Salt water enter in a cylinder, the piston expand and block the engine. Okay, what happened in that cylinder? That piston blocked, but the rest of the crankshaft tried to continue working. What happened in that specific cramping is fracture, and fracture the crankshaft and destroy the engine. Yeah, this is a very catastrophic consequence in a diesel engine. And yes, it's and the consequence is like this. You have this slide, and this is the fracture. This is the typical fracture. This is basically for lack of lubrication. Remember, the forces and the torques produced in a diesel engines are excessive. Alright? For that reason, keep the lubrication is critical. You remember 2 gauge, temperature gauge and oil pressure gauge. You need verify periodically that the oil pressure should be around in between 40 and 60 psi. Once again, depend on the manufacturer. Check the manual, but you need to be in charge of the oil pressure gauge and the temperature gauge. Okay, my friends, right now we are going to start with a process, with a wonderful process to remove the crankshaft in any type of diesel engine. Once again, my videos are not focused in Caterpillar, not focused in Cummins, not focused in both. No, my videos are generic, and you can apply those concepts for any type of engine. I love all the engines. John Deere is wonderful. Perkins, I love Perkins. Yanmar, wonderful. I love all of them. All of them are perfect. All of them have a good points and low point, but all of them are excellent. If you have a diesel engine, use it in marine application, it's because it's an excellent engine. Alright? Now I am going to explain the procedure to remove the crankshaft. And we are going to analyze different parameters in this procedure. Okay, the first step when we try to remove the crankshaft is remove the head. This is the first step. We are going to remove the head. Okay, we are going to prepare the conditions in order to remove the head. We are going to remove the head bolts, and we are going to prepare the chain and the conditions in order to remove the head properly. Okay, remember the heads in marine engines are heavy heads, and the recommendation is prepare the tools. Now we are going to leave the head. We are going to separate the head carefully. In this particular example, I am working in a good area with a good amount of tools, but when you do this procedure inside of the engine room, you need prepared conditions. You need prepare the frame, the I-frame that you have on the screen right now, and you need prepare too much tools. You need fabricate tools. For that reason, it's important, my friend, that you learn about the welding procedures. A good marine technician should be a good welder. Alright, we are going to continue. We are going to remove the head, and right now the head is out. The head is ready to separate the head gasket and start the process. Okay, right now we are going to remove the head gasket. This is the head gasket. We are going to put the head gasket in a flat surface with no humidity, in a dry area, cover it with plastic, and we are going to continue the process. Yeah, we are going to separate the head gasket. Remember, each time that you remove the head gasket, the recommendation is replace the head gasket for a new one. And the same with the bolts. The bolts are in place for 10 years, 15 years. Those bolts are extended. The recommendation is replace the bolts for original bolts. Original bolts, always use original materials, specific in this case. Okay, and right now we are going to start with the process to remove the fuel injection pump. This is very important in order to release the gears, the gear of the cam, the gear of the crank. Right now we are going to start removing the fuel injection pump. This is a long process. You remove the bolts, and right now we are ready to put the socket in front and remove the gear. In some cases the gear is hard to remove, and you need to use special tools like pullers like this, and with those pullers you can remove the gear easily. And after that you can separate the fuel injection pump in order to send the fuel injection pump to the matching shop in order to calibrate the fuel injection pump according with the manufacturer specification. Don't forget, when you remove the fuel injection pump in that point, it's because you put the engine at zero position. You remember the procedure that I explained in previous episode. Okay, right now we are going to remove the camshaft. This is another important element. Okay, we are going to remove the bolts for the flange that keep the camshaft in position. And now when you finish with all the bolts, we are going to remove carefully the camshaft. One person, carefully, one person. Okay, one person slowly remove the camshaft, always protecting the plain bearings on the journals. Exactly, always protecting the plain bearings. And right now you have the camshaft out. The camshaft is ready to be covered with a plastic and to be protected. Okay, and now we are going to remove the oil bracket. We are going to remove the oil bracket, and after that we are going to remove the oil pump. I'm going to explain the procedure. In some cases it's not necessary to remove the oil bracket, but in this particular example was necessary. Okay, we are going to remove the oil bracket. Be careful. This is the bracket where the oil filter is located. Where the oil filter is located, the dipstick is located, and additionally, for example, in this particular case here, on top of the bracket you can install oil pressure gauge, and you can install oil pressure sensor and a oil pressure switch to kill the engine in emergency. Alright, right now you have the bracket of the oil out, and we are going to remove the oil pan. This is the next step, is the removal of the oil pan. We are going to remove the oil pan quickly, and right now we have access to the oil pump. Alright, you remove the oil pan, be careful with the gasket. Now we are going to remove the timing flange. Okay, and now the crankshaft is ready. Those are the main journals. We are going to rotate the crankshaft in order to put the rod journals or cramping journals. Those are the rod journals or cramping journals. Exactly. The idea when you remove those journals is put the journals on top. Okay, those are the caps of the main journals, and those caps, they have special labels. Number 1, 2 dots, 3 dots for number 3, and 4 dots for the backwards. This is the nomenclature of this engine, and 5 dots for this one. And in this particular engine, the arrows face to the right side of the engine, and this is the front of the engine. This is the nomenclature in this particular Onan engine. It's a diesel engine Onan, and in this engine, the caps, they have arrows. You see the arrows? The arrows face forward, and additionally, on the caps, they have the letters. Exactly, this is the front of the engine. This is the front, and this is the letter F for front. And this one is the central, in the center, and this is the rear, in the back. Yeah, each engine have a different nomenclature in order to identify the position of the caps for main journals and rod journals, both of them. This is the forward, indicating that is in front of the engine. The same with the connecting rods. In this particular engine is one dot for the connecting rod number 1, 2 dots, 3 dots, and 4 dots, correct, per each connecting rod. Okay, the caps of the main journals, they sit on the block. They are bolted on the block. This is the block, and those caps are bolted directly on the block. Exactly the same like with the camshaft. The camshaft, they have a special rod, this one, and a special rod for the journals on the camshaft. And the gear of the crankshaft engage with the gear of the crank. You remember, normally the gear of the camshaft is twice in diameter with respect to the gear of the crankshaft. Exactly. And those are the caps of the main journals. Cap number 1, number 2, 3, 4, and 5. This is the last one. Those are the caps. And don't forget, the caps are bolted directly on the block, and the oil internally in the block they have a cavities passes where the oil pass from the oil pump and lubricate the block and the bearings. Right now we are going to check the holes on the bearings and the holes on the block where the oil pass and keep the pressure of the oil. Right now we are going to talk about that. This is very, very important. Okay, my friends? Alright, we are going to remove the main caps of on the journals. That's the procedure. We are going to be organized. We are going to prepare a table with a cardboard in order to put those caps. And those are the caps for the connecting rods. We are going to move the piston. We are going to rotate the crankshaft in order to bring in front those caps, in order to remove easily the caps of the connecting rods. You rotate the crankshaft and you bring the crankshaft easily in front in order to connect those caps. Alright, the piston is down, those pistons are up, and we are going to remove the caps of the connecting rods quickly. Be careful with the sockets. Use the appropriate socket. If you check the sockets, the head of the balls for the connecting rods, those head balls are 12 points, and the head balls for the main journals are 6 points. You need to select the appropriate socket. Be careful. Check that the socket doesn't have play. If the socket have a little play, it's because this is not the socket. Probably you need the same dimension in a standard, in the opposite or metric. Yeah. If you have a little play, this is not the socket. If you apply torque on the socket with play, you damage the head of the ball and you ruin the head of the bolt. And after that, you need a lot of time in order to remove only one bolt. Be careful with that. Okay, right now we are going to finishing removing the nuts. Be careful with the nuts. Okay, and right now you remove the caps and immediately you verify the condition of the bearings. This is a critical point, the condition of the bearing, the lubrication on that part. Clean the area, verify the condition of the metal on the crank pin and the condition of the metal on the bearing. In this particular case, those bearings are like new ones. Right? This engine is in excellent conditions. Alright, and right now, in order to remove the connecting rod, we are going to put in back the nut, because we are going to use a piece of wood to punch the piston out. In order to protect the thread of those studs, we are going to put in back the nuts. In some cases, I recommend cover the nut and the bolt with electric tape in order to protect the metal of the crankshaft. Okay, if you don't have experience, I recommend cover with plastic, with the rubber, that area in order to protect the crank pin, in order to avoid damage, dent, crack, the surface. This surface is critical. This surface should be polished. If not, the oil pressure of the engine goes down immediately. This is the area in between the bearing and the crankshaft where the pressure is created. Okay, now with a piece of wood, we are going to punch the piston out. We are going to move the piston out until other person receives the piston in the other side. My friend, check in this picture. This is the front of the engine. This is the front of the engine, and you see the mark on the piston. In this particular pistons, the mark is with the word front. Other pistons have the letter F. Other pistons have a dot, like the picture that you have on the screen right now. There are different marks, and you need to be careful with the marks. And if you check in this particular case, this is the front of the engine, this is the left side of the engine. All the marks of the valves are facing the left side in this particular engine. Alright, I recommend before you remove the pistons, take a picture of that situation in order to avoid inconvenience when you try to put them back, the pistons and connecting rods and crankshaft. Okay, we are going to continue. We remove the piston completely, and right now we have the piston out, and we are going to verify, very important, the condition of the rings. We are going to verify if the rings are broken, if the rings rotate easily with your hands, if the rings close properly. You try to close with your hands and verify if the rings close properly, and verify the condition of the piston. If the piston is if the piston can be reused, or if the piston should be replaced. This is a critical moment. You need to identify problems on the piston when you remove the piston. Okay, in this particular case, the O-rings are in perfect conditions. The head of the piston is good, and we are going to do the same with the bearings. We are going to verify the condition of the bearings in order to take a decision if we are going to replace the bearings or we are going to reuse those bearings in this particular case. Okay, you put back the bearings, with the cap, and close the cap in order to take the measurements. I am going to explain right now the procedure to take the measurements on the bearings in order to take decisions. I am going to replace bearings. What type of bearings I am going to use? Be careful with the caps. The caps only have one position, and be careful with the nuts. A special nut, a special thread, a special nuts. If you lose one of those nuts, don't try to replace for other similar nut with similar thread. No, because you destroyed the bolt. All right. You need to buy original nuts. Yes, you can buy the original nuts. Once again, if you have the parts, the catalog of the parts, you can order according with the part number the nuts appropriated for those caps. Alright, right now you organize in a table, properly clean with the labels, the pistons, cylinder per cylinder. You put all the parts according with each cylinder. Never try to mix it, the piston with connecting rod of piston 1 with piston 3 or vice versa. Never. You need follow the procedure, and the recommendation is never mix it, never switch the pistons, and of course never switch the caps of the connecting rods. If not, when you try to put them back, the engine is impossible. I am going to explain the procedure in another video, the procedure to assemble the engine again, step by step. Okay? Alright, right now we are going to remove the other piston. That is easy in this moment. And now we are going to remove the central pistons. Okay, we bring the connecting rods forward in order to remove easily the nuts. Okay, right now we are going to remove quickly the caps of the main journals. Once again, prepare the table, prepare the cardboard, the labels, and now we are going to remove the first one, and we are going to verify the condition of the bearings in that particular connecting rod. We are going to clean, we are going to clean with a rag both sides and check the condition of the metal on the crankshaft and the metal on the bearing. And we are going to do the same with the rest of the connecting rods, of the caps of the main journals. Okay, put on the table exactly in the position per each cylinder. If you need to use a hammer, try to use rubber hammer or bronze hammer in order to punch laterally the cap in order to remove the cap easily. Right now we have a other cap out. The bearings are in excellent condition in this particular case. I have another engine that right now I am going to show to yours with more deterioration because salt water entering. The condition is different. Look at the hole for the circulation of oil. We are going to talk right now about that. And this is the last exactly the last one. This one have exactly this side is for axial truss. In this particular case, this bearing have radial, and axial surface. Though exactly axial, and radial. In this area is produced the axial force. How is produced the axial force on the crankshaft? Axial. Yes, on the clutch. I don't have problem because the transmission in my engine is automatic. I don't have clutch. Yes, papi, you have clutch. You have hydraulic clutch. You have an intelligent clutch that I am going to explain in my book of transmissions. I'm going to explain the torque converter, how the torque converter works. The torque converter is a hydraulic clutch. According with the RPM, the hydraulic system expands and the clutch engage. Yes, if your transmission is marine, you have a clutch. You have a clutch pack, and the transmission is connected with the engine. But other element that produce excessive amount of lateral movement or axial movement on the crankshaft is the propeller. In your boat, if you have a propeller with high pitch, probably you have high axial force or thrust, and those bearings are destroyed. Yeah, and the crankshaft have too much play, lateral play. We are going to talk later about that. All right, this is the area where the surface, that surface, touch and produce high pressure with the oil. All right, for that reason, the condition of that metal, this metal here is babbitt or soft metal or white metal. That metal should be in perfect condition. How you know when this metal is gone, is out? It's normally when the color is like a bronze, it's like a yellow. It's because the white metal disappear and probably you have too much play. We are going to check with the feeler gauge the play on those bearings. Exactly. Those bearings have the same function than the bearings that I have in this moment on the screen. Exactly, the bearing that you have on the screen is like a half moon, have the same function. In some engines, the plain bearings with axial and radial force are located only in one bearing at the same. And in other case, those bearings, the axial bearings, are separated, like the half moon that you have on the screen, and those bearings are located in the middle of the crankshaft or in one of the ends. Yeah, but they have the same function. In other words, in some cases you have one bearing with both functions, axial and radial, or bearings separated, bearings for axial and the half moons for axial and the other one for radial. Okay. Yeah. This is the area for radial. In this particular case, exactly, it's exactly like this is the double function for axial here and radial over there. Axial, and that bearing enter in the cap and is used for both purposes. Before you put the cap on place, you need to be careful that the bearing enter completely. That bearing on top and engage with the bottom one. The bottom one have a groove. You see the groove? That groove? The oil is circulating through the groove. The oil is coming from the block, from this hole. The oil is coming from the oil pump. When the oil pump, you remember the gear of the oil pump engage with the gear of the crankshaft. Okay, when the crankshaft is rotating, immediately the oil pump is working, suction the oil from the oil pan, and circulate the oil at high pressure through the engine. If those bearings, if that material, the soft metal, the white metal on the bearings is gone, there are too much play in between the crankshaft and the block. And if the tolerance is not appropriated, too much play, immediately the symptom is low oil pressure. Okay? When the soft metal, the babbitt, is gone on the bearings, the first symptom is low oil pressure. You have low oil pressure on the oil pressure gauge. And additionally, if all of the bearings, the soft metal, is destroyed, you have other check engine code in the computer. The code is knock sensor. It's a knock sensor because there are too much play in between the crankshaft and the block because the bearings are gone. The life of the engine depends on the condition of the bearings. If the bearings are out, the oil pressure decreases and you have a lot of problems. Okay, this is very, very important. That groove is the groove for circulation of oil in order to keep the film of oil in between the metal of the crankshaft and the metal of the bearing at high pressure. The pressure normally is around 60 psi. Okay, this is a very, very, very important, and we are going to talk one chapter dedicated only to the lubrication system. Right, exactly. In this particular case, the top one doesn't have the groove, only in the bottom. But in the next example that I am going to show to you right now, both of them have the groove for circulation of oil. But you have plain bearings. Okay, look, this is the hole. This is the hole that circulate the oil internally in the crankshaft. Yes, the crankshaft is hollow. There are cavities of oil, like the picture that I have on the screen right now. Those cavities communicate the oil from the oil pump in the bottom and circulate on top through the bearings, pass through the crankshaft and enter in the next bearing and continue and continue. Like this example that I have for you. Look at this. If you introduce oil in this cavity, the oil goes out over there. Exactly. Or this one. You introduce the oil and the oil pass through the other hole. In other words, internally the hole, the crankshaft is hollow. Yeah, and through these holes, the oil is communicated to other bearings, and other bearings coming. The oil is coming from the oil pump, and the oil pump suction the oil from the oil pan. Yeah, this is very important. When you remove the crankshaft with air at high pressure, verify that those holes. Exactly the same with the camshaft. Let me explain. Don't forget, when you lift the crankshaft, we are going to introduce air at high pressure through the holes in order to verify that those cavities internally in the crankshaft are completely free. This is one of the steps before you put it back the crankshaft on the block again. Okay, other area where you found the plain bearings is on the camshaft. You remember the journals? Those are the main journals. This is main journals. This is main journal, and those are the lobes. The lobes in contact with the valves, and those are the main journals. The main journals are in contact with those plain bearings, babbitt, soft metal, white metal, and you remember I explained the procedure to introduce the camshaft. You need to apply a lot of grease here in order to avoid damage those bearings. Those bearings are critical bearings, and also they have a hole here in the bottom in order to verify if that the oil is in between the bearing and the main journal. You see the hole. Through that hole, oil is coming out, like the example that I explained before. The oil is coming out and produce a film of oil at high pressure, and this is the high pressure that you read on the oil pressure gauge. Exactly. Those are plain bearings, soft metal. You have plain bearings. Quiz question, you have plain bearings on the camshaft journals, and you have plain bearings on the crankshaft journals, in both main journals and cramping journals or rod journals, right? Okay, those are the plain bearings. Exactly, you have one plain bearing per each journal. Perfect. Now we are going to remove the crankshaft. The crankshaft is going out. Be careful. In this particular case, I prepare this special belt in nylon in order to protect the surface of the crank pins. Be careful with that. Never use the chain. If the crankshaft is a small crankshaft, you can use, I recommend 2 people, 1 in each end, in order to lift the crankshaft at the same time 2 people. But if it's a big engine, probably with this technique it's better. You locate in the center the rope and you lift the crankshaft from the middle. Okay, right now the crankshaft is going out with the crane, and finally the crankshaft is completely out, my friends. And now we are going to verify the condition of the crankshaft, the condition of the bearings here in the bottom, the condition of the bearings, the condition of the metal, and we are going to, with a small sandpaper, we are going to polish all of them in order to identify if I can reuse the crankshaft inside of the engine room, only replacing the bearings, or if it's necessary, send the crankshaft to the machine shop in order to process in a special machine, like the machine that you have on the screen right now in this video. Exactly, this is the machine used to rectify the surface on each journal. Yeah, this is the machine. The machine use special calipers in order to verify if all the dimensions are equal. Remember, my friends, according with the video that you have on the screen right now moving, the crankshaft is exactly like the piston rings and the bearings. Standard, plus 10, plus 20, and plus 40. You remember? We are going to use the same nomenclature, exactly the same. When you send the machine shop, the crankshaft to the machine shop, they rectify according with that procedure, and they return to use the crankshaft with the bearings recommended right now. Okay, this is very, very, very important. If you don't send the crankshaft to the machine shop, you can polish by yourself the crankshaft, and you order the bearings, the same bearing that you have before, oversized. I'm going to explain later what is the meaning of that. Yes, my friends, you can order standard bearings oversized or standard bearings undersized. You can order bearings plus 20 oversized or bearings plus 20 undersized. What is the meaning of that? A little thicker or a little thinner, oversized or undersized, to compensate. For example, this crankshaft is apparently in good condition, like the crankshaft that you have on the screen right now. Okay, because the crankshaft is in good condition, I am going to polish with a sandpaper number 800 or 1000. I'm going to polish exactly like I am doing on the screen right now, and I am going to check what is the dimension of the bearings right now. Oh, the bearings are plus 20. Okay, I am going to check the dimension of the crank pin of the crankshaft right now, and I am going to verify the dimension. On the connecting rod when the connecting rod is closed, and I am going to check the difference between the dimension in the connecting rod and the dimension on the crank pin. Okay, if that number is according with the range on the service manual, I can order the same type of bearings oversized, a little thicker. Yeah, and now when you receive the bearings, we are going to do a special process in order to verify if the tolerance is appropriate or not. This is the next episode, is the plastic gauge. Alright, this is exactly the process to remove the crankshaft and verify the condition of the crankshaft. Right now, in the next episode, we are going to check 2 important techniques. The first one is how to balance the crankshaft in a dynamic form. the dynamic balance. It's a special procedure. I recommend that procedure. And the last one is the procedure to check the clearance of the bearings. And we are going to use the technique of the plastic gauge. This is a simple technique. It's funny. We are going to do that process step by step. Thank you.